Hey guys, Mr. Pusky here. Hope you're having a good day so far. We are continuing chapter 10, which is factoring and polynomials. And just be aware, for this chapter, we're going to be jumping around quite a bit. So make sure you tell your classmates and make sure you're aware that we're doing 10.8 day 1 right now. We're going to be jumping around from the book a little bit, okay? Because we felt like the way that the book ordered the chapters was a little wonky in chapter 10, and this is a very important chapter, so we decided to take our own kind of style with it, okay? So, today we're working with, the name of the lesson is, ready, 1, 2, 3, factoring, finding the greatest common factor. Essential question, 1, 2, 3, what is the greatest common factor, and how do we find it? Okay, and there will also be a document I got to remember to post with you guys, that's going to be called the factor flowchart. And so this is going to be, what we're doing today is the first step in the factor flowchart that you should always check when you're trying to factor a polynomial. And so distribution is multiplication, factoring is like division. It's like we're trying to undo FOIL, we're trying to undo what's happening to the polynomial basically, okay? So the greatest common factor, we're going to go ahead and figure out what that means in a second here. So why don't you guys go ahead and list. So start by listing the factors of 24. It means, what's a factor? You guys know what a factor is? A factor is something that multiplies into 24 or goes into 24. So we're going to go ahead and do that for 24 and 40, okay? So figure out the factors of 24 and 40. Figure out what numbers multiply or divide into 24 nicely. Go ahead and do that. All right, the way I like to do these is I like to find pairs. So 1 times anything is going to be the number. 1 times what is 24? Yep, I like to do pairs and work my way inwards here, okay? Does 2 go into 24? 2 does. And what number multiplies by 2 equals 24? It's going to be 12. All right, does 3 go into 24? It does. 3 times what is 24? 3 times 8. What about 4? Does 4 go into 24? We got 4, and 4 times what is 24? 6. It's kind of goofy, we ran in the room there, but yeah, so these are all the numbers that multiply into 24. These are all factors of 24, okay? Now let's do the factors of 40, and the way I kind of did that, hopefully that makes sense, 1 times 24, that's why I put them outside, because we're working our way inwards. 2 times 12 go together. 3 times 8 equals 24. 4 times 6 equals 24. Okay, so basically what we're doing is we're trying to find pairs. It's easier to find pairs than to just keep counting up by one number each time and figure out what numbers multiply. Because once you get to the middle, you would have 5 and 5. Does 5 multiply to 24 or no? It doesn't. So, okay, what about 40? We got 1. 1 multiplies by everything. 1 times what is 40? 1 times 40. Does 2 go into 40? So the way you would figure this out, too, is you would just do 40 divided by 2, and 40 divided by 3, and 40 divided by 4, until you get to numbers that don't work anymore. 2 times what is 40? 2 times 20. Does 40 divide by 3? Or does 3 go into 40? Nope. Does 4 go into 40? It does. 4 times what is 40? 4 times 10. What about 5? Does 5 go into 40? It does. 5 times what is 40? I think it's going to be 8. Then we have 6 and 7. Do 6 or 7 go into 40 or no? They do not. Okay, so now we're looking for what's called the greatest common factor, and that's the greatest factor that they have the same. So it looks like they both have 1 and 1 together. They have 2 and 2, 4 and 4. So what's the biggest number that they have in common here? What's the biggest number they have in common? Hopefully you see here, it's going to be 8 and 8. So 8 is called the greatest common factor because it's the biggest number that divides into both of them. Okay? And another way to ask what is the greatest common factor they have the same is to say, we're going to zoom in here so I can write kind of big here, write kind of small actually. What is the largest number they are both divisible by? That's what saying what's the greatest common factor is what is the largest number they're both divisible by. Okay? I'm also probably going to attach, sorry, I'm getting a phone call here. I'm probably also going to attach a factor chart that's going to help you figure out what numbers go into each number, basically, okay? So, like, if you look at the number 100, it'll tell you what numbers go into 100. And you guys can feel free to use, a factor chart. You don't have to memorize all these numbers off the top of your head here, okay? I'm going to try and make it really easy for you guys so that you know what we're doing here, okay? So we have some examples to do 1, 2, and 3 there. It's saying what's the greatest common factor for each of these numbers. So you want to find the biggest number that goes into 20 and 25. And the biggest number that goes into 7, 21, and 28, and 5, 10, and 12. And be aware, there might be an option that they don't have anything in common. And what you would put for that, if they don't have anything in common, you'd actually put the number 1, because everything's divisible by 1, basically. Go ahead and give these a try. Oops. Go ahead and give these a try, and we will see how we did in a second. Okay, let's use a new color here. Let's use the cool pink. So what's the biggest number that goes into 20 and 25? I should have also mentioned you guys can use your factor chart too. What number goes into 20 and 25? What's the biggest number that goes into those? It's going to be 5. Okay. Okay, so 5 is the biggest number that goes into 20 and 25. That's a GCF. What's the biggest number that goes into 7, 21, and 28? Hopefully you said 7. And here's a trick for you guys. If you have multiple numbers here, the greatest common factor can't be bigger than the smallest number, which is 7. Because it's saying what number goes into 7. Well, you can't have 28 doesn't go into 7, right? That's too big. So the greatest common factor will never be bigger than the smallest number there. That's kind of a trick for you guys, okay? So 7 is the GCF there. What number goes into 5, 10, and 12? Is there a number that goes into 5? So 5 goes into both 5 and 10. Does 5 go into 12? No, and 5 only has the factors of 1 and 5. Only 1 times 5 goes to 5. So actually 5 doesn't go into 12. The GCF is just going to be 1 for this one. Or you could say it does not have a GCF. It's just going to be 1. Let's say I should keep that there. Okay, oops. All right, now we're going to get a little bit trickier here, guys. So stay with me, okay? So, greatest common factor with variables. So what we're going to do the same thing. We're going to do the greatest common factor for the numbers in front, but we're also going to do for variables, okay? The GCF for exponents on a variable is always the smallest, always the what? Always the smallest exponent on each variable, okay? So first let's go into this here. So we have 30 and 20. We have 30 and 20. What's the biggest number that goes into 30 and 20? What do you guys think? It's going to be 10. 10 goes into both 30 and 20. There's no other numbers that are bigger than 10 that go into both 20 and 30. Now, this gets a little bit trickier here. So now we have x to the third and x to the fourth. We have x to the third and x to the fourth. Now, which exponent is smaller, 3 or 4? Hopefully you said 3 and you know what numbers are bigger and smaller. If you're not, I'm a little worried about you. It's going to be x to the third is going to be our GCF. It's going to be whatever the smallest exponent is going to be. And then we have y, or y to the first, and y to the fifth. Which number is smaller, 1 or 5? It's 1, so we're going to put y. So it's just a little bit trickier, but it's not. It's still a little bit trickier, I guess. But it just gets a little confusing when you have like really big stuff you're looking for GCFs out of. But it's always going to be the smallest exponent that you have there, okay? What would happen if we had just, if we had 30, x to the third, y to the y, and let's get rid of the y here. What if we had this, and we had 20, x to the fourth, y to the fifth? Could we pull out what's the GCF for the y's? What's the smallest exponent for y's if there's no y? It's going to be y to the 0, or it just kind of goes away, right? So actually, if there's no y there, you can't pull it out, okay? This means the smallest number that you can pull out of the y's here, this one has a y to the fifth, this one does not have a y. So it's going to be just no y. You're not going to pull out a y because they don't have it in common. It's the greatest common factor, what they have in common. Okay, why don't you guys go ahead and try 1, 2, and 3 on your own, and we will get this out of the way. You guys can give it a try. All right, next. So, what's the biggest number that goes into 8 and 24? Hopefully you said 8. And what's the biggest or smallest exponent, x to the third or x? So 8x is going to be our answer. Nice. All right, and then we have 25, w to the third, 30, w to the fourth, and 15 w squared. So what's the biggest number that goes into 25, 30, and 15? Hopefully you said 5. And then what's the smallest exponent? 3, 4, or 2 in the w's? It's going to be 2, so we get 5w squared. All right, and then the last one. Is there a number we can pull out of these, or no? I see negative m to the fourth and negative m to the third, or just positive m to the third. There's no number you can pull out. You don't always have to pull out a number. If there's no number there, you don't need to pull it out. Okay, what's the smallest exponent there? M to the fourth or m to the third? So we're going to pull out m to the third. And what's the smallest p? P to the fifth or p to the seventh? P to the fifth. And there we go. Okay, now let's get into the actual fun part where we're actually doing some factoring. All right, factoring up the GCF. How do you determine what goes in the parentheses? What we're going to do is we're going to divide, we're going to what? Each term by the GCF. By the what? By the GCF. So we have 20x plus 35 equals, they already found out that 5 is the GCF for those two numbers right there. So what we're going to do is we're going to divide, and I'm going to do it right now, I'm not going to do it all the time, but we're going to divide both of these by 5. That's what's going to go in the parentheses. I'm going to show you why that works in a second here. So what is 20x divided by 5 going to be? That's going to be 4x. And what is 35 divided by 5? Plus 7. Now, why did we do that? Well, like I said before, factoring is dividing, and like we're undoing like distribution. We're undoing multiplication. Now, let's just go ahead and remultiply this without doing it real quick and show you what I mean. What's 5 times 4x going to be? That's 20x. And what is 5 times 7 going to be? See how we got the same thing, which is 35, 20x plus 35? So factoring is undoing distribution, and distribution is multiplying, basically, okay? So we're trying to undo we're dividing each of those by the GCF. It pulls things out and makes it, this is going to be nicer. When we have 4x plus 7, it's going to be easier to work with than something that's a little bit bigger numbers and stuff, okay? All right, now which one should we try together here? Let's do number 2 together, and you guys will try number 1 on your own, okay? So it looks like they pulled out our GCF, which is 5x already. So we need to, and I'm not going to write this out every time or I divide by 5x underneath all of these, but just get in the habit of knowing when you're pulling out a 5x, you're dividing each of these by 5x, okay? So what is 10x squared divided by 5x going to be? Hopefully you said 2x. And what is 25x to the third divided by 5x going to be? Well, 25 divided by 5 is 5. And then also, what do we do with exponents when we divide them? That's a good thing to remember. When we divide exponents, what do we do with them? We subtract them. So what is 3 minus 1 going to be? It's going to be 2. And then we have 15x divided by 5x. What's 15 divided by 5? It's 3. And then what's x divided by x? Well, those are going to cancel. If you remember a while ago, we were doing stuff like this, where like, how many x's are going to cancel in these ones right here? Yep, 1x is going to cancel. We're going to have 2 left on top. How many x's are going to cancel over here? 1x is going to cancel. We're going to have 1 left on top. That's what we have over here. Okay? All right. Why don't you guys go ahead and do number 1 on your own? All right, number 1. Okay, 4x squared is the GCF. So we're going to divide all these by 4x squared, and eventually, like I said, I'm not going to put the 4x squared underneath each of these. You just need to know that when you pull out a GCF, you're going to be dividing them all by that number. So what is 24 divided by 4 going to be? It is 6. We're going to have x to the, we have x to the fifth over x squared. What's 5 minus 2 going to be? It's going to be to the third. And then we have negative 28x squared over 4x squared. What's negative 28 divided by 4? It's negative 7. And then what's x squared divided by x squared? Those are going to cancel. It goes to 0. Okay, and there's our answer. All right, a couple more things here. Thanks for sticking with me, guys. Thanks for your hard work. Okay, so checking your answer, which is the correct form of this? So basically what it's asking for is which was the correct GCF, okay? So what we need to know is we need to plot the biggest number that goes into both those terms and also the smallest exponent. So what's the biggest number that goes into 8 and 16? Hopefully you said 8. And then what's the smallest exponent, x to the third or x squared? X to the third or x squared? X squared. So which one pulls out 8x squared? This one does. This is the correct one. So these are all wrong, but let's look at why they're wrong in a second here, okay? Why don't we go ahead and let's look at this one down here, okay? Let's look at this one right here. So they pulled out 4x squared, which is fine. Okay, but now look at is there a number that goes into 2x and 4? Yeah, you can actually pull out a 2, right? There's a 2. What's 2x divided by 2 going to be? It's x. And what's 4 divided by 2? Plus 2. So they did not pull out, they pulled out something, they pulled out a factor, but they didn't pull out the greatest common factor. Because you see, this is still going to multiply to 8x squared like it is over here. So you can pull out smaller factors, but it doesn't really help you because, like, we want to pull out the greatest common factor, okay? So that's why these other ones are wrong, because they didn't pull out the greatest common factor. This one right here, this one has x squared in common, right? They can pull out an x squared. This one down here, they can pull out an x. They didn't pull out the biggest x. So yeah, that's kind of what I'm getting at right there, okay? Let's do this. Gonna clean it up for the thing here, okay? So another way to tell is that look in the parentheses and make sure that the factors only have the number 1 in common, only the number what? And then use the distributive property, use the what? Distributive property to multiply the problem back together. So the correct form is 8x squared times x plus 2 because it has the GCF taken out of the binomial. So looking inside the parentheses here, what's the biggest number that goes into 1x and 2? What's the biggest number that goes into 1x and 2? Well, 1. And then do they both have an x in common we can pull out or no? This one doesn't have an x right here, so we can't actually pull out an x. So our GCF is going to be 1. That's how you know you pull out the greatest common factor, is if the only thing you can pull out is a 1. All right, sounds good. So let's go ahead and do just a couple more examples, and then we'll call it a day here. We're not going to do the check. We're just going to do this one. So let's do number 3 together, and then you guys can try 2 and 1 on your own. For number 3, we want to find the greatest common factor. We're going to pull something out, and then we're going to pull out the GCF. So we have 14, 21, and 7. What's the biggest number that goes into all 3 of those? Can't be bigger than 7. What number is multiplied to 7? 1 and 7. Does 7 go into all 3 of those? It does, so we can pull out a 7. And then, what is the smallest exponent that you guys see here? We have 3, 1, and 4. What's the smallest exponent there? It's a 1. We're going to pull out 7x. Okay? And now we're going to divide all 3 of these by 7x. So go ahead and do that really quick. Divide all 3 of those by 7x. Okay, 14 divided by 7 is 2. What is x to the third divided by x going to be? 3 minus 1 is going to be x squared. What is 21 divided by 7 going to be? It's 3. And then we have x over x. Those x's are going to cancel. What is negative 7 divided by 7 going to be? Negative 1. And then what is x divided by x to the fourth? Or sorry, x to the fourth divided by x to the first. X to the third. That was sloppy. So another way you could write that is 7x, 2x squared, plus 3, dang it, minus x to the third. Okay? Why don't you guys go ahead and pause the video and do 1 and 2 on your own, and I'll give you the answers here in a second. Okay, the answers for number 1, you'd pull out a w. When you divide them both by w, you're going to get w minus 10. So that's going to be your final answer, because w, you can't pull out there's a 1 here, you can't pull out a 1, it's not going to do anything, but then they both have a w in common, that's a GCF. Down here, what's the biggest number that goes into 24, 20, and 36? It's going to be 4. And then, oh, sorry, I goofed. And then what's the smallest exponent we can pull out of there? This one doesn't have a t over here, so we can't pull out a t, so it's just going to be 4. When we divide that, we're going to get 6t to the third plus 5t minus 9. And there's your final answer. Okay, I'm going to probably post a little tutorial, hopefully, on how to use the factor chart. Or maybe I'll just post a little, like, typed out thing for you guys. But thanks for watching. Hopefully this makes good sense. And I hope you guys have a good day. Make sure you get your homework turned in. This will be Thursday when you're watching this, so make sure you get turned in by Friday at midnight if you want feedback on it, and we're going to have a mini quiz probably on Monday. So thank you guys for watching. Have a terrific day, and we will see you soon.